acetone is partially condensed out of a gas stream containing the balance already performed here. You can take a look from this diagram. Okay, the question is calculate the required rate here. So we need to determine the Q here. So the first step is to perform the balance already done. So our first step is perform the balance. And then the second is to eliminate or make assumption from the equation. Q minus equal to delta H plus kinetic energy plus potential energy. So from this expression or equation, you may eliminate the certain part. Okay, since this is a condenser, our system is condenser, there is no moving part, so work shower equal to 0. And then for the kinetic as well, there is no mention about the velocity, so we can ignore it as well. And also the potential energy can be ignored by assume that all the rate here is leaving and entering the system at the same direction. And then the third is to form this reference state. So we have acetone and also nitrogen. So for acetone is you may choose the state based on from the table by producing the table. For example, let's produce the table first, and then you can know how to perform this. So the table is we have the substance here. And we have the input, mole second, and we also have H input. We have this N out, mole second, and then we have H out, kilojoule per mole. So the substance we have acetone in liquid, we have acetone in vapor. Okay. This is, we start with the vapor, follow the stream. Vapor, liquid, and nitrogen. So for the N mole here, okay, we already have the information here. Okay, how to choose the reference here. So we have this N1 is given, and then for the liquid, there is no input. So we can ignore the specific enthalpy for acetone in liquid, and then nitrogen also we can calculate. Okay, for the vapor we have okay, we have both vapor and liquid, so we can get this, and then output, and then this one also, and then nitrogen. Do we have nitrogen? Okay, we also have this nitrogen. So to select the reference state, so you may choose either vapor or liquid condition. So based on this, because the first stream, we also have nitrogen here, so we may choose this as your reference. So you can neglect this system. Okay, example here, if we consider as acetone in liquid at 20 and 20 degree and 5 atm. So you may, if in this table, we may neglect this by consider it as, or neglect this H output, because we can perform the balance based on this stream and this stream only. So cannot consider this one. So it's easier for us to solve this. Okay, for the nitrogen, since it involves all the species in the process, so we have nitrogen in gas. So the temperature is at 25 degrees Celsius and 1 atm. So you can, this reference temperature for the nitrogen here is 25 degrees Celsius and 180 M. Okay, and then we can insert the information here. The number 5 is to insert the information. Okay, let's we insert the information is right, and then 31. So this is considered at 1, and then this is your H2, 3.35. 3.1. So this is your H3 and your H4 to perform the, because Q equal to delta H. Delta H equal to output M HI minus in M HI. Okay, so for this, we can proceed to the H1 first. H1, we can see here H1 for acetone in vapor. H1 is acetone in vapor and 65 and also 180 M. So the initially or reference here we have acetone liquid 20 degrees Celsius and 580 M. Okay, if we take a look for the term here, we have the different phase, different temperature, and also the different pressure. Okay, the from the reference to the desired condition as the stream 1 here, it cannot be changed simultaneously. That means you should perform one by one for each term. Example here, that's why for H1 here, we can calculate it based on the part function. So maybe we start with, this is our reference. So 580 M. So we need to, maybe we can change the pressure first. So still in the liquid at 20 degrees Celsius and to 180 M. And then after that, we can change this temperature. So liquid in, okay, 20 to 65. You need to go back to your reference table and check the boiling point of the acetone. So from table B1, boiling point of acetone is at 56 degrees Celsius. So if you change from the 20 degree to 65, that means you already changed to term here from the liquid straight away to the vapor phase because the boiling point is at 56. So we need to have the 56 first at 180 M. And then after that, we have the from the liquid to the vapor at this condition or this temperature, and then we can change to the AC vapor at 65 180 M. So our step is, okay, this you may consider as H1A. This is H1B, delta H1C, and delta H1D. Okay. To calculate the H1 here, H1 equal to delta H5 or equivalent to delta H1A, delta H1B, delta H1C, and delta H1D. So for each part here, delta H1A here, okay, for the different P, delta P plus, for delta B here, we have 20 to 56, right? So this is Cp in liquid, delta T plus C here we have 56 to, okay, since we have the same temperature, So we have the different phases here. So we may have the delta because then we need to find the delta H for the vaporization here because the vaporization process occur here. And then, okay, we have the different temperature. So from 56 to 65, Cp in vapor dt. Okay, and then to solve it, you may, okay, example, delta H1A V delta P. Okay, V here, you may refer to the table B1 for acetone. Okay, V. So we have delta 1 minus 5 atm, delta H1B. It involves the Cp. So you may refer to all the information are listed in table B1. So for the delta, okay, I will give you the answer. This is equal to 0.0297. Okay, this is 4.68. And then delta 1C equal to 1D equal to 0.753. So the delta H1 equal to 35.7 kilojoule per mole. Okay, the rest H2 here, or H2 here, you may refer to this since it has the same temperature and pressure as acetone. You may follow the same step. The answer for H2 is 1.16 kilojoule per mole, and H3 is 32 kilojoule per mole, and then your H4 is minus 0 kilojoule per mole. Okay, the delta H equal to output Ni Hi minus input Ni Hi, and then equal to minus 2320 kilojoule per second. Thus, you can get Q equal to delta H equal to minus 2320 kilojoule per second, or equal to kilowatt. Okay, so this is how you solve this problem. Okay, in summary, for non-reactive, okay, this is the information if involving change in pressure or change in space. You may consider whether this process is melting or vaporization process. And then if involved with a change in the temperature, so you may consider based on the constant volume of pressure, whether the Cp in liquid or Cp in vapor. All the information may be referred to table B1. Finally, you can get this Q.